All right. Hello, DC Chem. What we're going to be doing today is we're going to go over video 2, so the Chapter 2 video 2 review, which you should have watched before class today. I'm going to go over the objectives, what you should know. Then I'll go through this review. Then I'll show you on your practice problems some stuff that you can do on your practice problems now that we've done video 2. So here are the 4 objectives up at the top. For video 2, first, you need to be able to convert a number to and from scientific notation. Second, identify leading zeros and trailing zeros in a measurement. Third, identify the amount of uncertainty in a measurement. And fourth, identify the degree of uncertainty in a number written in scientific notation. So here we go. Question 1 says convert the following numbers to scientific notation. Well, remember, to convert to scientific notation, the number that you convert to has to be a number between 1 and 10. So notice this says 23. It is not a number between 1 and 10, so I need to convert and move that decimal point 1 spot to the left. So this would be 2.3. But then, because I move that decimal point 1 spot to the left, I need to do times 10, and then the exponent needs to be the number of spaces that I moved it to the left. So it would be 1, just like that. So 23 would be 2.3 times 10 to the first power. Letter B, same thing. The number needs to be between 1 and 10. So now I need to move that decimal point right there in between the 1 and the 0. So this is going to be 1.0940. Then I need to do times 10. And because I moved that decimal point 2 spots to the right, it's going to be times 10 to the second, but because it's to the right, it's going to be to the negative second power, or the negative 2 power. So if you move the decimal point to the right, it's a negative exponent. If you move the decimal point to the left, like we did in letter A, it's going to be a positive exponent. For letter C, our decimal point technically is right there. So I need to move this 1, 2, 3, 4, 5 spots to the left. So it's going to be 9.60085 times 10. And because I had to move that decimal point 1, 2, 3, 4, 5 spots, it's going to be times 10 to the 5th power. This last one, oh man, that's a tiny number, but let's count these decimal places. 1, 2, 13, 14, 15, 16, 17, 18, 19 spots. So this is going to be 7.890 times 10 to the negative 19. There is the number, those 4 numbers converted to scientific notation. So now in number 2, we have the numbers in scientific notation. We need to convert them to standard notation. So notice here, our first number, 2.34 times 10 to the 5th power, we are going to take that number and we are going to convert it to standard notation, which means I need to move this decimal point because the exponent is 5. I need to move that decimal point 1, 2, 3, 4, 5 spots to the right. So it's going to be 2, 3, 4. Then I need to add in 1, 2, 3 zeros because there'd be a 0 there, there, and there. So I'm going to erase that just because it's kind of cluttering up my number there. But I need to basically add 3 more zeros. 0, 0, 0. There's my standard notation for that number. Then for letter B, notice my exponent is now a negative 3. Well, when it's negative 3, I have to move it back to the left. It's got to go back this way. So I need to move it back 3 spots. And because there's 2 numbers there or 2 zeros that I need to add in, those are going to go right there. So it's going to be 0.00, and then those numbers after it, 0.003247, just like that. Number 2, letter C. This right here, you may recognize this number. It's Avogadro's number, 6.02 times 10 to the 23rd, but we're going to write it in standard notation. That means I need to move this decimal place right here 23 spots to the right. Well, just to save some time, notice I already have moved it 2 spots to the right. Well, that would take my 23 down to 21. So that means I need to take that number, 602, And now I need to add 21 zeros behind it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. There is Avogadro's number written out in standard notation. That's a big number. Number 3, how many significant figures are in number 1 in part A? Well, let's talk about significant figures. Number 1 in part A, there are 2 significant figures here. So this right here, 23, has 2 significant figures. This right here, same thing, 2 significant figures. So a number is significant if it's just a number, like not 0. It's always significant if you see a number that's not 0. That's why both of those are significant. So how many significant figures are in 1A? There are 2. Number 4 says put a line through the placeholder zeros in number 1 part B. So placeholder zeros are the zeros that come first. They're the ones at the front. Those are placeholder zeros. So if you need a definition of placeholder zero, those are the ones in the front. Those are these right here. So I should be putting a line through those first 2 zeros. Those are placeholder zeros. So I've done that. Put a line through the placeholder zeros in number 1, part B. Number 5 says put a line under the sandwich zeros in number 1, part C. Well, sandwich zeros are exactly what you'd think with a sandwich. In a sandwich, you got the bread, then you've got what you put in, then you've got your meat or if you're making a peanut butter and jelly, you got your peanut butter and jelly, and then you have more bread. So sandwich zeros are zeros that occur in between 2 non-zero numbers. So it said to draw a line under the sandwich zeros in number 1C. These right here are the sandwich zeros. It's those 2 zeros. Those are the sandwich zeros. Then letter C says circle the trailing zeros in number 1, part D. Trailing zeros. So trailing zeros in number 1, part D, trailing means at the end. So it says to circle those. That is the trailing zero in number 1, part D. It is that single zero at the end. So now it says, how many significant figures are in number 1, part B? Well, let's talk about what makes a zero significant. So, in number 1, part B, it says that we have placeholder zeros. So in number 1, part B, this number right here, we have placeholder zeros. Those are the front zeros. And what I want to tell you is placeholder zeros are never significant. Okay? Placeholder zeros are never significant. Then let's talk about sandwich zeros. So in number 1, part B, that is a sandwich zero. Sandwich zeros are always significant. So that zero is going to be a significant figure, a significant number. Then let's talk about the last type of zero that we discussed. That is a trailing zero, this zero right here. Trailing zeros are significant sometimes. It depends on the context. So here's what it depends on. Trailing zeros are significant if they occur after the decimal point, or if they occur to the right of the decimal point. So this trailing zero that I've circled right here, this would be a significant zero or a significant figure because it comes to the right of the decimal place. So if I'm counting these significant figures here, all 5 of those numbers would be significant. Okay? So let's go back and let's answer that question. How many significant figures are in number 1, part B? We said there are 5. Now it says, how many significant figures are in number 1, part C? Well, let's look at number 1, part C. Well, in number 1, part C, we have the numbers that are non-zero are always significant. And remember, I said sandwich zeros are always significant. So that means the 9, the 6, the 2 zeros, and the 8 and the 5 are all significant numbers. So we would say in number 1, part C, there are 6 significant figures. Then number 9, how many significant figures are in number 1, part D? Number 1, part D. All right, well, remember I said these placeholder zeros, these all right there at the front, remember I said those are never significant. So those numbers we're not going to count. Then this 7, this 8, and this 9, those are always significant because they're not zeros. So those are significant numbers, the 7, the 8, and the 9. Then remember I said trailing zeros, it depends. And the trailing zeros are significant if they occur after the decimal point or to the right of the decimal point. Notice this 0 right here is to the right of that decimal point, which means we will count it as a significant figure. So that means this would be a total of 4 significant figures. So number 9, the answer is 4 significant figures. Number 10 says, why is putting a number in scientific notation helpful in determining significant figures? Here's why. If you put a standard notation number in scientific notation correctly, the number of digits that you wrote down is the number of significant figures. Let me show you. Notice our answer here has 5 numbers in it. Look at what we put for the answer to number 7, which said how many significant figures are in number 1, part B, and we said 5. Which is the exact number of significant figures that we have in the scientific notation, right there. Then, in letter C, notice that there are, if I look at these numbers, there are 6 numbers there in that front number on the scientific notation. And look at the answer we put in number 8, which the question was, how many significant figures are in number 1, part C? We said 6. Which is the exact amount of numbers in this problem right there, in that front number. Okay? Then let's look at number 9. Or excuse me, let's look at number 1, part D. Notice that in the scientific notation for number 1, part D, look, there's 4 numbers there, 7, 8, 9, and 0. And look at our answer to how many significant figures are in number 1, part D. We said 4. So, why is putting a number in scientific notation helpful in determining significant figures? It shows the significant figures. I'm going to put sig figs, short for significant figures, in the front number of the scientific notation. Then number 11 says, because of the answer to number 10, how many sig figs are in number 2, part B? Well, let's look at number 2, part B. Here it is right here. Here's number 2, part B. How many numbers are in front of that? Guess what? There's 4. That means the answer here is 4. Number 12 says, in number 5 on the other side of the paper, how many sig figs are in the volume reading from the graduated cylinder? So we're actually going to go back to the video 1 review. Back to the video 1 review, and it said in number 5 on the other side of the paper. So here's number 5 on the other side of the paper. We recorded, remember I was looking at this meniscus line right here, and I said we needed to figure out or read the accurate volume of that. And remember, on a graduated cylinder, you read from the bottom up. So this was 2, this is 2.5 right there, this is 2.6. We knew it was between 2.6 and 2.7, but we made an educated guess at the next decimal place. So this was our volume, 2.66. Well, look at those values. We have 3 numbers there, 2, a 6, and a 6. So that means the answer to our final question here on the video 2 review is that there are 3 sig figs in that number. Now, here's what you're going to be able to do. Now that we've done the video 2 review, I'm going to close out here and go to our extra practice problems. You should have this in your folder. Remember, these are the problems we do for every chapter, and remember, they are due the day of the Chapter 2 quiz. In numbers, this is question 1. In these questions, notice it says, identify the number of significant figures for the following numbers. You can do that now. Number 2 says to round each number to the place of the underlined number. So on these types of problems, you're going to go, all right, in number 1A, this is 2.0. Then because it's underlined here, I'm going to look at the number behind it. It's a 1, so I'm going to round that down. I'm just going to write 2.00. For letter B, notice that it's going to be 0.00, and I need to round this to, well, I need to look at the number behind that 2. Since that number is a 5, if it is a 5 or higher, I'm going to round to my underlined decimal place. I'm going to round up a number. So this would be 0.003. Okay? Then on number 3, it says write the following numbers in scientific notation, and it gives you those numbers. You're going to do exactly what we just did in our video review. Write those numbers correctly in scientific notation. All right, that's it for today. When we get back, we are going to talk about video 3. So for homework, you need to watch the video 3, chapter 2, video 3 on Canvas, and then we will go over that video review on Wednesday. Thank you for watching.